We're going to look at a couple of examples of finding a polynomial function of a certain degree with a given number of zeros. So this one is degree 3. That means I have 3 zeros or 3 factors, and it tells me what the zeros are. So the first thing I want to do is write my polynomial in the form f of x equals a times x minus h1 times x minus h2, etc. So for this problem, my f of x is equal to a times x minus a negative 3, x minus 1, and x minus 4. Now, it didn't give us any other information to have to take into account, so my a value can be anything I want. I can make it be, well, I guess it can't be 0, but I could make it be 1, negative 1, 1/5, 1/2. I'm just going to leave it 1 because we have found a function that has those zeros. Now, I could multiply these all out. I don't need to, so I'm not going to. Now, we can make this process a little more involved. The same question that I saw before, degree 3, zeros at negative 3, 1, and 4. However, we've added in this extra piece. So we're going to do what we did before. We're going to start off by writing our function in the form f of x equals a times x minus a negative 3, x minus 1, and x minus 4. Now we have to use this other information to determine what a is. So I know that f of 2 is equal to 30, but I also know that f of 2 is equal to a times 2 plus 3 times 2 minus 1 times 2 minus 4. So a little substitution here. 30 is equal to a times 5 times 1 times negative 2. Or I could say that 30 is equal to a times negative 10. In other words, a is equal to negative 3. So my equation that I'm looking for is f of x equals negative 3 times x plus 3 times x minus 1 times x minus 4. And again, you can multiply that all out if you want, but you don't need to. Here's another example. It's got some terminology in it that you may or may not have heard. We're going to find a polynomial function of degree 3 with zeros at 1 and negative 1 with a multiplicity of 2, such that f of 2 equals 9. Now, first of all, it says degree 3, but it only gives me 2 zeros. And that's where this right here comes into play. Multiplicity of 2 means I have 2 of these zeros. So we're going to start off by writing f of x equals a times x minus 1, that's my 0 at 1, times x minus a negative 1, but I've got 2 of those because that's what multiplicity of 2 means. Now I'm going to do what I did before. F of 2 is equal to 9, but f of 2 is also equal to a times 1 times 3 squared. Well, 3 squared is 9, so my a value is equal to 1. So the function I'm looking for that meets those characteristics is f of x equals 1 times x minus 1 times x plus 1 squared.